I mean, we hear about it constantly, right? It's plastered on every cereal box, every energy bar, and basically every health blog on the internet. But despite all of this noise, the actual biological science of how our bodies use protein remains hugely misunderstood. So today, we're going to fix that by looking directly at the clinical evidence.
But before we map out today's deep dive, I really want you to ask yourself, do you actually know how much protein your body requires? Or are you like millions of other people blindly following dietary advice that actually dates back to the 1800s? I know it sounds absolutely crazy, but many of the rules we follow today are based on some very old, very flawed assumptions.
Believe it or not, the modern protein obsession started way back in the 19th century. A researcher named Dr. Karl Voigt was observing German coal miners, guys doing back-breaking physical labor for 12 hours a day, and he noticed they were eating about 120 grams of protein daily. Now, instead of just noting this as a casual observation, he arbitrarily recommended 120 grams as the standard for everyone. It literally wasn't a scientific prescription for health, it was just a description of what coal miners ate. Yet, this created a massive dietary myth that persists to this very day.
So here's our agenda for today. First, the great protein obsession. Second, muscle protein synthesis explained. Third, the leucine threshold. Fourth, sarcopenia and aging muscles. Fifth, busting common protein myths. And finally, your optimal protein intake. All right, Chapter 1, the great protein obsession. Where did it begin? Well, the confusion really starts with the very name itself. Coined back in 1838 by a scientist named Mulder, the word protein was derived from a Greek word meaning to be first. Taking that word for word, it immediately gave the nutrient this false sense of supreme importance. Shortly after that, a famous German chemist named Dr. Liebig noticed that muscles were mostly made of protein. And because of this, he incorrectly assumed that protein must be the primary fuel that muscles burn for energy. He was dead wrong, but the idea just stuck in the public consciousness forever.
Moving on to Chapter 2, Muscle Protein Synthesis Explained. Building blocks.
Let's break this down word for word. Muscle protein synthesis. Synthesis essentially means combining components to form a connected whole. When you eat protein, your digestive system breaks it down into individual amino acids. Think of MPS like a biological construction site. Your body uses these amino acids as structural bricks, not as the fuel to power the machinery like we used to think, but as the actual physical bricks to build and repair cells, skin, organs, and muscle tissue. A major systematic review from the University of Exeter uncovered the real mechanism here. I want you to notice a really crucial word in this quote: augments. It means you need both the dietary bricks from your food and the physical stimulus of resistance exercise to actually build muscle. Without the physical stimulus of resistance training, just having a bunch of extra bricks sitting around the construction site won't magically build you a bigger building.
Next up, Chapter 3, the leucine threshold, the ignition switch.
Okay, so leucine is one of your 9 essential amino acids. Essential meaning your body cannot make it. You absolutely must get it from your food. Scientists hypothesize that a specific dose of ingested leucine acts kind of like an ignition switch. You basically have to hit a certain threshold or a specific dose of leucine in your bloodstream to effectively flip that switch and initiate that entire post-exercise muscle repair process we just talked about. Now, what is absolutely fascinating in the data from that Exeter study, especially when you look at the older participants graphed out here, is this clear linear relationship. The research found that older adults require a significantly higher dose of leucine, a much greater and faster peak, to trigger the exact same muscle-building response as younger adults. Basically, the ignition switch gets a lot harder to turn as we age.
Which brings us to Chapter 4, Sarcopenia and Aging Muscles. Protecting your muscles.
Sarcopenia translates literally from Greek as poverty of the flesh. It is the completely natural decline in muscle mass that happens to all of us as we age, but it's not a slow, steady decline forever. The loss accelerates dramatically after age 70, where the rate of muscle loss almost doubles, reaching up to 15% per decade. That's huge. This is exactly why preventing muscle loss isn't just about looking good. It is a matter of maintaining your independence and your mobility. So, the crucial point researchers at Exeter found is this concept of anabolic resistance. As you age, your body goes through real alterations in digestion and absorption. Your muscles literally become less sensitive to the protein you're eating. Because your body becomes less efficient at utilizing those amino acid bricks, a higher overall intake of protein becomes absolutely vital to combat sarcopenia and keep your strength up.
All right, Chapter 5, busting common protein myths. Fact versus fiction.
Let's kick this off with a real who-whopper of a myth. You've probably heard that high-protein diets will destroy your kidneys, right? Well, a comprehensive meta-analysis overseen by Dr. Stuart Phillips at McMaster University definitively debunked this 50-year-old myth. They found zero evidence linking a high-protein diet to kidney disease in healthy adults. Now, obviously, those with existing diagnosed kidney disease must be careful and restrict protein under medical supervision. But healthy adults? You have absolutely no evidence-based reason to restrict protein just to protect your kidneys.
Here's another massive myth that just falls apart when you look at the science. There's this persistent, stubborn belief that you have to eat meat to get complete protein. The reality? Plants produce all 9 essential amino acids. By simply combining different plant proteins throughout your day, like, say, rice and beans, you are providing your body with every essential building block it needs. Furthermore, some plant proteins, like soy, are highly bioavailable and completely nutritionally complete entirely on their own.
And this one brings us right back to Dr. Liebig's historical mistake from the 1800s. Eating excessive amounts of protein does not automatically make you stronger. Muscles do not run on protein. They run primarily on glucose and fats for energy. Without the stimulus of resistance exercise, your body simply takes all that excess protein, processes it, and either stores it as fat or excretes it. It's that simple.
Finally, Chapter 6, your optimal protein intake. What's your number?
So for a completely sedentary average healthy adult, the baseline recommendation from health authorities is just 0.8 grams of protein per kilogram of body weight per day. Let's do the math. If you weigh 70 kilograms, that's only about 56 grams of protein a day. Remember our 19th century coal miner who was eating 120 grams? The actual scientifically verified baseline is less than half of that old historic myth. But as you can see from this data from the PA Foundation, that baseline definitely changes as you age. If you're a healthy adult over 50, your requirement jumps up to 1.0 to 1.2 grams per kilogram. This is exactly how you actively combat that anabolic resistance we talked about earlier. And look at the far right column. If you're dealing with an illness or an injury, your body needs even more structural bricks to repair itself, pushing the daily requirement to 1.2 to 1.5 grams.
So here is your ultimate cheat sheet. The big takeaway is to tailor your intake to your specific age and activity level. If you are actively lifting weights and trying to build muscle, aim for 1.6 to 2.2 grams per kilogram. But remember, balance is key here. Medical consensus suggests that consistently exceeding 2 grams per kilogram over the long term for average adults just isn't necessary. And pushing to extreme upper limits could actually increase risks like intestinal discomfort or kidney stones.
As we wrap up this explainer, I really want to leave you with a provocative question to help you rethink your nutrition. Are you just eating for today, or are you actively applying the science of leucine and sarcopenia to protect yourself for the future? By understanding how your body actually uses protein as structural bricks triggered by exercise, rather than just some magical fuel source, you can ensure you are preserving your strength, your mobility, and your independence for decades to come.
If you enjoyed this video, give it a thumbs up, subscribe to the channel, and hit the notification bell so you never miss another science-backed fitness video. Thanks for watching, and I'll see you in the next one.